Hello friends, welcome to Prismatic online class. In today's class, we are going to look at eigenvalues and eigenvectors. Sometimes eigenvalues and eigenvectors. Now, the eigenvalues is determined by the characteristics equation matrix A minus lambda I into is equal to what? 0. While the eigenvectors is determined by the characteristic equation of matrices what A minus lambda I into what x all equal to 0. Okay, the question says determine the eigenvalues and engendered what vectors of what matrix A equals to 3, 4, 2 minus 1. So 2, 1. Solution. Let's start. What do we do? Recall that this is equal to A, the eigenvalues, the eigenvalues, values is equal to what? Matrix. This minus what? Lambda what? I equal to 0. And always recall that I is equal to 2 by 2. Identity matrices, which is 0 or 1. Record that from our identity matrices. So now what do we do here? We have this in as our A is given, which is 3, 4, what? 2, 1. Close it. Minus, what is this in our lambda? Lambda that is multiplied by, what is identity matrix? 0, 1, 0, 0, what? 1. Close it. All into what? All equal to what? 0. What do we do? When we have this is equal to 2, 3, 4, 2, 1, close it, minus 1, lambda times 1 will give us what? Lambda. Lambda times 0 will give us 0. Lambda times 0 will give us 0. Lambda times 1 will give us what? Lambda. Close it. Okay. Okay, close it. All equal to what? 0. Okay, what do we do now? We add and subtract inside. 3 minus this, we have 3 minus lambda. 4 minus 0. 4 minus 0, which is 4. 2 minus 0, which is 0. 1 minus what? Lambda, which is 1 minus what? Lambda. Or is this equal to 0? This is determinant. So we need to find what? Determinant of the what? Okay. 2, this is 2 minus 0 will give us 2, not 0, 2. So now let's go. We need to find what? Determinant of this matrices. That is 3 minus lambda multiplied by 1 minus what? Lambda. Close it. Minus 2 times 4. Close it. All equal to 0. Now let's go. 3 into 1 minus lambda over it. Minus lambda into 1 minus lambda over it. Minus what? 8 equal to 0. Okay, let's solve. 3 times 1 will give us 3. 3 times lambda will give us minus 3 lambda. Minus lambda times 1 will give us minus lambda. Minus lambda times minus lambda will give us plus lambda square minus what? 8 equal to 0. Okay. Now, what do we do again? Well, let's start somewhere else here. Okay. Okay. Now, from this place we have 3 times 1, 3. 3 times minus lambda, minus 3 lambda. Minus lambda times 1, minus lambda. Minus lambda times minus lambda, lambda square, minus 8 equal to 0. Okay, collection of like time, we can collect. We have 3. Minus will give us minus 4 lambda. plus what lambda square equal to what? Okay, minus what? Minus 8 equal to 0. You collect again, it means 3 minus 8 minus 4 lambda plus lambda square equal to 0. In this place, we can turn this in. We have this in as lambda square minus 4 lambda. 3 minus 8 will give us minus 5. Minus 5 equal to 0. This is a quadratic equation. So we need to what? Solve it quadratically. Either by what? Either by a factorization method or what again? Or almighty formula. But let's find two things that when we multiply we get 5, but when we add them we get this. We have this thing as lambda square minus what? 5 lambda plus lambda minus 5 equal to 0. Partition them. Lambda square minus 5 lambda, close it, into what? Plus, okay, yes, into what? Lambda minus 5, close it, equal to 0. Now we have lambda into what? Lambda minus 5 into this relationship here is what? Plus 1 into what? Lambda minus 5, all equal to 0. So hence we have that lambda plus 1 equal to 0, or lambda plus minus 5 equal to 0. Hence, make lambda subject. Lambda is equals to minus 1, or lambda equals to 5. And that is our egg what value. So our egg values are lambda equals to minus 1 and lambda equals to what? Minus 5. So that is our egg what value. The engine values is equal to what? Minus 1 and what? 5. So that is the. So now let's look at what? The engine vectors. Engine vectors which is this a determinant of a minus lambda I into what? X equal to 0. Now we have already know our a. Now when lambda we get from here, let's assume when lambda we pick when lambda equals to equals to 5. From this place we have that our a, which is what? 3, 4 minus. So from the normal distance, which is a 3, 4 minus what? Let's just go direct without wasting time. This is 3 minus lambda 4. This is what? 2 into what? 1 minus what? Lambda, or into this. And we have x. This will be what? X1, x2. Close it. Is it equal to what? 0. Now our lambda is equal to 5. So what do we have now? 3 minus 5, 4, 2, 1 minus what? 5. So you replace lambda when it is what? Lambda is equal to 5 into what? X1, x2. Close it. Is equal to 0. Now this is what? 3 minus 5 will give us what? Minus 2. 4, 2, minus 4. Close it into what? X1, x2. Close it. Equal to 0. Now let's go. This multiplied by this multiplication. Minus 2 times x1 plus 4 times x2. 4 times x2. All equal to what? 0. Now 2 go to this. We have a 2x1 minus 4. 2 go to this minus 4 to this, which is what? 4x equal to 0. Okay. I hope you are done. Okay. Now let's go. From this question we can have that 2 minus 2x1 is equal to what? 4 minus 4x2. Now divide both sides by the coefficient. Coefficient is minus 2 minus 2. This will cancel, this will cancel. So we have that x1 is equals to what 2 what x what 2. Now, which means that our x1 implication of s1 is equals to 2 into what 1. So when eigenvalues is equals to lambda equals to 5, the eigenvectors is equals x1 equals to 2 and what 1. So that is thing. So now let's test when lambda equals to minus 1. When lambda equal to minus 1. From this place we have that 3 minus 1 into 4 and 2 into what 1 minus 1 and into what x1 x2 close it is equal to what to 0. Now let's go. This is the same thing as saying okay, this is the same thing as saying what 3 into 3 into what 3 minus will give us 4. So we have it as 4. This one's 4 what again 2 what 2 close it into what x1 x2 close it is equal to 0. Now let's go. 4 multiplied by x1 we have it as what 4x1 plus 4 times this we have it as 4x2 is equal to 0. 2 go to this 2x1 plus what 2 what x 2x2 equal to 0. Make the subject equation 1. Assume equation 1, equation 2. Make equation 1 4s the subject of the formula. From equation 1, 4x1 is equals to minus 4x2. So divide both sides by what coefficient 4. This will cancel, this will cancel. Hence x1 is equals to minus x2, which will give us that x2 itself is equals to what coefficient, which is 1. The coefficient of x which is what minus 1. So the eigenvectors, when eigenvalues is equal to 1 minus 1, the eigenvectors is equal to what 1 and what s2 equals to 1 and what minus 1, and that is the implication of it, and that is how to solve the equation. When the eigenvalues is equal to 5, after solving you get that s1 is equal to 2 and what 1. But when eigenvalues is equal to lambda equals to minus 1, after solving you get that our s2 is equal to 1 and what minus 2, and that is how to solve it. Thanks and God bless you. Remember to subscribe to my YouTube channel Matrices Online Class, and follow me on my WhatsApp, on my Facebook Matrices Online Class. Thanks.